Again, the course research methods and design. We are going towards the end of the course, towards the outcome of your research. Today we are going to talk about the last step in your research, which is the results. In the results, you show us all the product of all your efforts, all the hassles, the troubles you have been through, and you present them to us. And the results is considered to be the essence of your research, the main thing of your research. We do research because we want to reach an outcome, to reach a conclusion, or to reach some kind of results to help us fulfill our research objectives. If our objective is to improve, we hope to reach some results that help us to improve. If our objective is to find weaknesses, we hope the results help us to find these weaknesses. If our research is just to describe situations, we hope the results to describe very well the situation we are interested in. So today we are going to talk about results, and it's very important in results that you know the structure of the results, how to structure your results and how to present them. As we are going to see in a minute, presentation of the results is very, very important. If you present them very well, in an interesting way, well, that's going to attract your readers. But if your results are presented in a very dull way, very likely that your readers will be disinterested and may not like your research or may not continue reading your results. So today we are going to know how to present the results or the structure of results and different types or elements or different categories of presenting results. And then we don't have time to talk about discussion and conclusion, but I'll mention them by the end of the lecture, just to show you how important to have some discussion and conclusion, and what are the differences between results, discussion, and conclusion. So let's start with the structure of results, or results in general. Three statistical things to do with results. So we have we have presentation, as I told you, very important that you know how to present your results. Mainly presentation consists of making easy to understand tables and especially graphs of various sorts to go in the main text and show the key features of the results. Yes, in results, you try to make things very easy to the reader, especially if you are going to use tables and graphs. You need to explain these tables and graphs. Let's say that you want to just describe your school, how many Saudi teachers and how many non-Saudi teachers in your school, and then you present them in two graphs. Don't say, well, the graph is very clear that the Saudi teachers are more than the non-Saudi teachers. You have to say this in the text. You have to write this. Don't say, well, the graph is enough to show that who is more than the other. No, you need to make things easier to me. Don't leave it to the reader. Don't say, well, my readers are very smart and they would know that from the graph they can read the graph. No, don't think that your readers would read the graph. They might not have time to read the graph because maybe they are skimming your research and they are just looking for some specific results. Or maybe don't think that they are you would have all your readers smart. Maybe you have readers of some sort of lower level of reading, especially if you are writing in English. Don't expect all your readers to be able to understand your graphs. Sometimes you have very simple graphs, but sometimes you have very complicated graphs. So you need to make things easier to your reader. Try to describe the graphs and tables to your readers. For example, histograms, bar charts, scatter plots, line graphs of various sorts. For these tables or graphs, frequencies of people falling in a category may be converted to percentage for easy understanding, and often what will be presented are descriptive statistics derived from the data rather than scores or whatever of each case separately. So what does that mean? So if you have graphs and tables, you may want to convert these into percentages instead of just saying, well, we have 300 Saudi teachers in this university and 150 non-Saudi teachers in this university. You may want to just convert them into percentages. You would say, for example, 75% of the teachers are Saudis, 25 are non-Saudis. So this is more easier than just presenting numbers in tables. Teachers, Saudi teachers, 300, non-Saudi teacher, 150. No, it would be easier to convert them into percentages. So this is one way to make things easier to your reader. One thing to do with the results is to make descriptive statistics. What do we mean by descriptive statistics? In all results, you always start with descriptive statistics. Again, the example of Saudi and non-Saudi teachers in a university. If this is your research, you would start, as I mentioned earlier, by telling us the descriptive statistics that you have 300 Saudi teachers and 150 non-Saudi teachers, which is 75% and 25%. This is called descriptive statistics. You only describe the numbers in your data. Sometimes, if you are gathering attitudes, let's go back to the example, attitudes of learning English language. If you have, for example, 3 attitudes, one is positive and one is negative, and the third is in between. Is not towards negative attitudes or not towards positive attitudes. So in this example, you would tell us how many participants in your research said they have positive attitudes, and how many said they have negative, and how many said that they have neutral, in between attitude. So they are not into positive or not into negative. So in the descriptive statistics, you would tell us how many in these 3 categories, and then you want to show us something called the mean. Let's say that you have here in the positive 100, and in the negative is let's say 50, and in between 25. Okay, so then we want to know the mean between these 3 categories. Why the mean? Because by the mean, by showing us the mean score, you can tell us the results of your research. If the mean is more towards positive, you would say, well, mostly all the participants have positive attitudes towards English. If the mean score is towards negative, you would say that my research participants have negative attitudes towards English. So let me repeat this because this is very important. Let me rephrase the example by simple numbers. Let's say that you are given a negative 0, neutral 1, positive 2. And then you ask your participant to choose either negative, neutral, or positive. Let me write this. So we have here a scale 0, 1, 2. So either negative, or neutral, or positive. And then you ask your participants to choose their attitudes. They have to choose only one. So they choose either 0, 1, and 2. You have, for example, let's say 300 participants. This is just an example. And then you try to count how many out of these 300 selected 2, and how many selected 1, and how many selected 0. You gather all of these numbers, and then you split these you split the totals into what is called mean. If you do not know how to calculate the mean, you can do this in different softwares, PC software like Excel, like SPSS, different programs to compute or to calculate the mean for you. Let's say that you get a mean of 1.5. This is the mean score after you calculate the mean. So 1.5 is here. So what is the result of your research? The result is that your participants or your population is going more towards positive attitude towards English. You cannot say they have, all my participants have positive attitude. Why? Because you don't get a perfect 2. If all your participants choose 2, then you have a mean of 2. Why? Because all of them selected 2, selected positive. Then you can say all the participants have positive attitudes. But in this case, since you get a mean of 1.5, you would say, well, most, not all, most of my participants have positive attitudes towards English. Again, 0, 1, 2, positive, neutral, and negative. How about if we get a mean score of 0.5, which is where? Which is here. 0.5 would be here. Then what is your results? The results would be, well, most, notice, most, not all, most of my participants have somehow or some kind of negative and neutral attitudes towards English. Why? Because most of them have fallen between the categories of negative and neutral. This is the importance of showing the mean. The mean is always related to descriptive statistics, or what we are going to mention here, measures of centrality. The mean means the centrality of the scores of your results, where they are centered. Are they centered in one category or between two categories? Then you need to be specific in your describing your results. Like here, You cannot say, well, all of them have negative attitudes. Why? Because you have a mean of 0.5, which is here, between negative and neutral. So you need to be specific in describing your results. You would say, most of my participants have a negative and a neutral, something in between negative and neutral attitudes towards English. So descriptive statistics, these are figures you get the computer to calculate. As I said, you use computer to calculate these figures or these numbers, like Excel, space S, and unfortunately we didn't have time to have a lecture to show you these software like Excel and SPSS. So you use the computer to calculate from a lot of specific figures which arise from data. Essentially, they summarize certain facts just about the specific cases you studied. Hence, they are referred to as statistical measures based on observed data. Sometimes referred to as O, observed, figures for short statistical tests, and C, which go beyond just what has been observed about samples. Mainly they are of one of the following types, depending on what kind of thing about your people, words, etc. they measure. So as I said, from your observed data, you have data, you observe them, and then you observed these numbers of figures. You get the computer to calculate these, what we are going to talk about, the mean and standard deviation. So measures of centrality, these in some way indicate the one score or category that you might choose to represent a whole set of scores or categorization for one group of cases on one variable. These are mostly familiar measures from everyday life. One example is the average score of a set of interval scores, technically the mean. So this is what we are talking about, the mean. Another where you have cases that have been put in categories is the category that the greatest proportion of people chose or fell in. So this is the category that the greatest proportion of people chose or fell in. Like the example here, where is the greatest proportion? All your people fell in here or here or here. Then you show this is the highest category or the highest score that my participants selected. Don't bother about these definitions. What's important to me that you understand the idea and then you can describe them in your own words. So these are measures of centrality. We want to know where our data are centered so we can describe them, or we can depend on them to reach a result. Measures of variation. These summarize how far the individual scores were closely spread around some central measure. How far they were widely spread. In a way, they measure how closely the scores or people who scored the scores agreed within a group on a scale running upwards from 0. The higher the figure, the greater the variation. Examples of such measures are the standard deviation and related notions, variance and error for scores, index of commonality for categories. So we have standard deviation. Standard deviation is how spread the scores from each other. Let's say that in this example that most of our students are here, located here. They have fallen here between negative and neutral. We want to know how far these results from each other and how far from positive. Do we have here some participants that they selected positive? So the greatest the number we get after we calculate, we get something called standard deviation. From standard deviation, the number, if it is great, then the answers for our students or the scores are spread, not very close. The smaller the number, that means they are very close to each other. So what's important here to me, that you know that we want presentation to be simple and easy. This is A. You know the mean. The mean is very important, because based on the mean we can have results. We can have some confidence saying, well, this is my results based on the mean that we have. Standard deviation is how closely or far the scores. What I mean by scores is your participants, your students' answers, are they close for to each other or not? Let's say that you are asking your students, is this course easy or not? And the answers agree, disagree, in between. You want to know how closely their answers to your questions. Are they all agreeing that it is easy, or are they disagreeing among each other, and you get a very spread answer? 5 saying disagree. Let's say that you have 25 in your class. 5 saying disagree, 10 saying easy, and 10 saying in between. So you see, spread among. They are not centralized in just one answer. This is in brief and as a simplification of this idea. Also, we have something called measures of difference. Let's say that you have differences in the answers. Let's go back to the example of using computers to teach English. And you have teachers in your school, and you ask them this question: what do you think of using computers in your classroom? And then you get some saying, well, it is very effective, I like it. And you would have some answer saying, no, it is not effective, I don't like it. So you have two answers here. Either they like it or they don't like it. Let's say that when you calculated how many said I like and how many said I don't like, and you get this result. For example, you get 40 saying like and 38 saying don't like use computers in their classroom. Well, obviously you have a difference here, 40 versus 38. But can you say, well, there is a real difference in the opinions? No, you cannot say. Well, because the difference is only in 2 teachers. They're almost even or equal in their views. So you cannot say, well, there is a difference among the teachers. You cannot go to the headmaster, to the principal, and say, well, I gathered all the teachers and they disagreeing. They don't have, there is a difference between their views. No, you cannot say this. You can say, well, I asked them and I got something like 50 saying yes and 50 saying no. So you cannot judge and say, well, since we have this, we should use computers in our classroom. No, because here, although they are disagreeing, but you cannot say there is a real difference among their views. Why? Because the difference here is not great. But how about if you have 28? Well, you need a computer. You need a software to calculate what is called the measure of difference. There is a real difference between 40 and 28, and we want to reach a level called the level of significance. This is very important, and I'm going to repeat it today maybe hundreds of times. The level of significance should be something like 0.05. It's called P. the probability significance equals 0.05. How do we get this number? By computer. There are special programs, special software to calculate the differences. We enter the numbers, click enter, and you get this number. If you get this number and less than this number, then it is called in research significant difference. And this is what we are looking for in research. We always are looking for significant or significance. If it is significant, well, then you are standing on a strong ground to say, well, I have a result that is significant, and I can say confidently that there is a difference between a blah and a blah. But if you get this number and above, well, no, it is not difference. If you get something like 0.06, it is not difference. And you have to make sure that there is a difference between 0.05 and 0.50. There is a difference. It should be 0.05. This is the level of significance that we want to reach in order to say, well, we have significant results. So if we go to the computer and we enter the number 40 and 28, please tell us the what is called the p-value, or the significance, or the significance level. Then the computer is going to show it to us. If it is 0.05 and below, it is significant. If it's not, it is not significant. Then we cannot say, well, we have a difference. And this is very, very important in research, especially if you want to show that there is a difference between a blah and a blah. And let's have another example. Let's say that you used computers with your students. You have 50 students, and you use computers with them to explain grammar for a semester, for 3 months. And another group, another class, you used with them no computers at all. You used only papers and textbooks, also for one semester, for 3 months. And you want to show, you want to convince us that there is a difference. We as a reader, or experts or researchers, we want to see your p-value. If it is 0.05, well, we will say, yes, we agree with you. There is a difference between the two classes, between the students that you use computer with and students without computers. But if it is not at the level of 0.05, something like 0.50 or 0.1 or 0.2 or 0.4 or even 0.06 or 0.07, then it is not significant. So this is the measure of difference. Either we have a real difference, significant difference, or there is a difference, but it's not significant, or there is no difference at all. So these summarize the amount of difference between pairs of samples or groups measured, or between scores the same group obtained in different conditions, usually by a figure that is the difference between two means, or the difference between two percentage difference. Again, such figures normally run upwards from 0, no difference, to any size, as we showed here. Measure of relationship. This is another difference. You may want to present in research not differences, but relationship. Let's say that you want to prove to us that the more you use computers, in learning English, the higher the scores you get in the final exam. So the relationship between using computers and getting higher marks. So here is a different story. You are not looking for differences, but between relationship. Or let's say that you want to prove that if your age is young, you are going to learn English faster than who are older in age. So the relationship between age and learning English. You want to see, is there a relationship between age and learning English? So this is called measure of relationship. So these quantify the amount of relationship between two or more variables as measured in the same group of people or whatever. They are usually on a scale from 0 to 1. So if you get something like 1 relationship, that means there is what is called positive correlation or positive relationship between your two variables. I'm not going to dig into this too much because it's very sophisticated, talking about Spearman coefficient, Kendall's, whatever. This is just for your pleasure, for your information. If you want to get more information, these are for your extra reading. See, inferential statistics. This has to deal with the p-value. I talked that if you want to get this p-value, you go to the computer, you click a button, and you get the p-value. This is done through what is called inferential statistics. We use some kind of statistics, and these statistics have names. If you go to statistics classes, you will get all of these statistics about Fraidan, about ANOVA, about t-test, and you may have been told all of these names in your statistics classes in Arabic. I'm not going to dig more into these, but just to give you that sometimes you use inferential statistics to reach this p-value, just to prove to us that after you did your research, you found a relationship or not. You found a difference, a significant difference or not. The level of certainty is about what inferential stats tell you that you will be satisfied with. No inferential statistics give you 100% certainty. After we do research, we cannot be 100% certain that these results are 100% perfect. No, you should have some margins of error, and this is calculated to be 5% at least in your research. So you can be 95% that your results are good, but you have to say that there is a margin of 5% of error, because there is nothing perfect. So the level of certainty is 5%, and as I told you, significance level to be at 0.05. So 95% is the percent that we can reach. This is the maximum that we can say about whether we are certain, because sometimes we do research and because we want to reach some critical decisions. This is why we need to be certain about our results. But unfortunately, we cannot be 100%. So also, again, this is for your pleasure about the certainty of your results. Significance test. Here is I talk about these significant tests. These deal with hypotheses about differences or relationships, as I explained before. Either we want to reach some kind of difference or relationship, which is why it was a good idea to think in these terms when formulating hypotheses and planning what to do in the first place. Before actually starting gathering data, they tell us if a difference or relationship we have observed in samples is strong enough to indicate a real difference relationship in the population sampled or not. So we use these significance tests, as I told you, just to give us a boost or confidence that yes, we have a real difference or a real relationship. How? Through the level of significance, which is here. The p-value, the probability value is less than 0.05, which is 5%. Suppose you are comparing the attitudes of men and women to RP. You find an observed difference between the results for two samples, one of men and one of women. RP is reading proficiency. So you want just to see the attitudes of men and women towards reading proficiency. What I mean by reading proficiency is to be proficient in reading. You read very fast, listeners or people can understand you, and you can understand yourself while reading. This is reading proficiency. And you want just to collect attitudes of men and women. Is it important to have to be a proficient reader or not? So we have this design or this research, and then we run a test. We get the p-value. If it is below 0.05, well, then it is, we have a real difference in the attitudes. If not, if it is bigger than 5% or 0.05, well, we cannot say it is significant. This is the technical term. We want to start to use technical terms to look professional in front of others. And this is the essence of studying and education. Education is to help us to be professional and to use the terminology outside the classroom. So you get distinguished from others who has no education. So the technical term of getting this real difference is significant difference. So in your research, you need to use the word significant. When you say I have a difference, it has to be either significant or not significant. So if the probability is reasonably large or bigger than 0.05, then it is not safe to regard the no difference hypothesis as rejectable. So you have a hypothesis, and based on the p-value that you are going to get, you would say, well, my hypothesis is confirmed or rejected. Let's say that your hypothesis say, well, men will have positive attitudes than women, and you get a p-value of 0.05, well, then your hypothesis is confirmed. But if you get a p-value larger than 0.05, and you get, for example, from your data that the woman has more positive attitudes than men, then your hypothesis is rejected. You can have what is called the null hypothesis. This is just for more information. The null hypothesis is that there is no difference. You get an equal 50% for men and 50% for women. So there is no difference in your research. So this is about results. We are going to to visit this website and see some graphs. here is a simple graph of writing performance in English. Writing performance in English, and here on this side you have the number of students starting from 0 to 3 students, and then here you have their scores starting from 40 until actually starting from 0 to 100, but here from the graph we see that the lowest score is 40, so it's starting here from 40 to 90. So after you collected your data about your students' writing performance in English, you gave them an essay or a composition, and then you marked the composition, and you just want to know the performance. So you enter the data in your computer, one click, you get this graph about your students. So here we can say that you have here one student having a score between 40 and 45, and here you have 3 students at least getting 55, 60, 65, 70, and then some student here, 2 students got 85, and here 1 student got 90 out of 100. So just by looking at the graph, where do you see the scores are centered? It's centered here in the middle between let's say 52 here and maybe 73. Why? Because this is the largest number. We have here 3 students getting between 55 and 65, and 2 students having a score of 70. So by describing this, the graph is very clear, but you need to describe it to us. You would say, well, most of my students are centered between 50 and 70. They're marked between 50 and 70, and depending on the pass mark. At KFU, we have the pass mark at 60, but let's imagine that in this case the pass mark is 50. So you would say that most of your students have passed your exam. Why? Because most of them scored more than 50 out of 100. But still, you got 2 students failed. Why? Because one got 40 and the other got 45. So you have 2 failure students here, and you have the rest passed your exam. And then you would say, well, maybe my exam wasn't too difficult and also wasn't too easy. Why? Because most of them scored what is called a middle scores from 50 to 70. Only 2 and 1 here got a higher score or a good score, 85 and 90. So you see, from a graph you can generate too many things, and these things can be helpful, for example, to your teaching, to your exam. So you see, just about your exam, you were able to get too many results, only about one sheet of exam. So think about if you do a real research involving a lot of data. So just from one exam, you got this graph showing you a lot about your students. So here another way of showing the same thing, writing performance in English. These all examples about different things, and it shows us these graphs and how to explain them. Here it talks about the constructs of your students' writing, how many they scored in spelling, in punctuation, in grammar, in vocabulary, in organizing their ideas, and so the length of their writing, the appearance of their writing. You may have allocated scores for each of these components. For spelling, for example, you gave them 8 out of 100 out of 10. For punctuation, students scored 4 out of the highest is 4 out of 10 or out of 5. It depends. This is just to show you where your students lie. So the highest they got is in spelling and appearance and organization, and this is very simple, very sensible. Why? Because students care very much about the appearance of their writing. They try to decorate it with flowers, roses. They try to type it sometimes, use colors. So they care about the appearance. And this is why they scored high in the appearance. Organization, well, they were very good in organizing their thoughts. Spelling, maybe they cared about their spelling. But still, they have problem in grammar and vocabulary. This is why they got lower scores. And also about ideas, length, maybe because they are not high proficient, they couldn't write too long essays. So you see, you can manipulate all of these graphs, getting different results about your students. And by research, you see, we can base our judgments on solid grounds and strong grounds and say, well, you see, I did research and I got these results. You see, I can confidently say, well, I need to do blah, 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 or we need to do blah, blah, blah. So hopefully, after we get all of these results, we describe these results, and then we start to discuss these results. Let's say that you did this research, and your friend or another researcher from another part of the world did the same research. Let's say that you got some, let's say, different results from him. You need to discuss these results. You have to say, for example, my results are different from that researcher, and you have to explain why there is a difference. Maybe the difference is because you are from different countries and you have different students. Maybe the difference in the tools. You used questionnaires, he used interviews. Maybe his objectives were different from yours. You have to say this. This is called discussion. Discussion is to compare your results with others, or to compare it to the literature review that you mentioned before. This is discussion. And what comes at the end is a conclusion. Conclusion is the summary of your research. You summarize, I did blah, 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 and the conclusion from my research is blah, blah, blah. We always try to reach a conclusion. Based on all of this research, the conclusion is blah, blah, and this is very, very important. And also what is important, that you can say, for example, I couldn't do much with this research. One further recommendation is to pursue or to continue my research. And this is very important, that we start our research from what others or where others have stopped. You always would find these recommendations for further research in the conclusion. After conclusion, you get the references. You need to list all the references that you refer to, all the books, all the articles, all the research that you refer to in your research, and it is written in what is called APA style. This is the most common used style. APA, you need to use some certain rules of writing the references, Unfortunately, I don't have a list here with me, but if you are interested, you can email me and we can talk more about referencing and this stuff. This is the end of this lecture, the end of this course. Hopefully it was enjoyable. We will all see you in the 14th lecture talking about the final exam and the revision. So thank you for listening and attending this lecture.